Welcome to all my combo lords joining me. Normally this stream, which is a weekly thing, at least for March, will be happening at the right time, 5 minutes early, but it just rained out here today, and we'll talk about the raininess in a moment. In any case, as this large chart behind me shows, I have a bit of a schedule this March because it's the last month of grade -1 here in combo class. And perhaps if we just began and it cut in midway, what we are going to jump into today is our 10 a.m. Pacific time, where I'm from, stream of the month and possibly onward that we'll be doing, called Modular Mondays. And to a degree, it's just a normal live video that I'll be doing, which will, as usual, be time-stamped with some chapters afterward for anybody who wants to watch it afterward or who missed some stuff, because these streams do always contain some chunks that are full of mathematical knowledge, like a video of mine, and also do contain some funny moments and other random little visits from nature or stories or so on. And it is different times for other folks, as they're noting in their time zones. This stream at 10 a.m.-ish Mondays, and by 10 a.m.-ish, I mean it will start at 10 a.m., but it'll last not sure how long amount of time, 1 or 2 hours usually, maybe sometimes more, is starting somewhat on a weekday or school day for many people in my time zone, Monday at 10 a.m. However, I have viewers in all sorts of time zones, and for those in my time zones, those may be more able to join my Threeven Thursdays, which I'll be doing from this month and possibly onward, which will be at 6 p.m. in Pacific time, here California time and other times here, which is the PST or PT one you'll see. And for other viewers in random time zones, I wanted to give you all a chance to join me live, because although these videos will be time-stamped and such, live joining gives you the opportunity to hang out with other combo lords in the chat and ask me questions. I will have periods of each of these streams where I check the chat, and as my viewers know, I do like to go on long tangents where I don't, so that I can have nice little concrete chunks for future viewers that do give a little lesson or story on their own. But in between those, I like to check the chat where I can kind of answer any questions you might have or reflect on any thoughts you want to add. To start with that, somebody asked if I'm going to be doing more philosophy videos, and I will. I have a lot of philosophical thoughts I want to share. In fact, I haven't really considered myself to having done any fully based philosophical videos so far. I've woven in philosophy into many of my episodes, but pretty much all of the episodes have had a topic that's either math or some sort of scientific thing or other break or something. But I do want to do some episodes that lean heavier toward philosophical thoughts, which will of course include actual facts as well mixed in. And those will come as the grades go further, and will also continue to be woven in various places. And one of the more philosophical things coming up will be the finale of grade -1, which will be coming later in March. I don't want to set an exact date for that, although I know the next episode coming on the main channel, which is the final exam, and will be a fun video even for people who don't intend on doing that, will be coming on the 12th, so that'll be the next episode. But at some point later in March, not sure exactly when, the finale will be ready. And that will be somewhat philosophical as I go through the story of making this grade, some of the behind-the-scenes footage you may have not seen, maybe some cameos from some of the camera people who have helped me, and other rarities. More destruction rituals related to the resetting of the grade. And grade -2 will be coming in early April. Now, to whoever's wondering if the result of X mod Y, can it be negative? And to whoever's saying that somebody else asked a poor question, I don't think these were poor questions, so it makes me less likely to want to answer your question, honestly. I think we should encourage each other's questions. And the result of X mod Y can be considered negative, but it's less the inputs that I'll talk about for a moment, because we are going to see something related to negative outputs of the result, as you mentioned, which is if I say something like, I'm in mod 100. Well, mod 100 means that I have some sort of cycle with my numbers where every 100 gets me back to 0. And it would actually be similar to the last 2 digits in RBase, because I haven't gone into this in much detail yet. There will be an episode clarifying this sometime, but we've talked about how a mod is similar to the last digit of a given base, but we could also say it's the last 2 digits of other bases once in a while, such as how, in this case, base 100 would have its last digit be whatever we're talking about, but we would need 99 different non-zero symbols for that. And so that's going to be confusing to keep track of. Mod 100 also can refer to the last 2 digits and the patterns those will have in base 10 for the last 2 digits. And we can imagine that by noting that the number like 301 has looped around 100 a few times like a clock, like one of my many clocks, and these loop around after 12. Although clocks are written terribly, it should have a 0 on top. The range of the clock that we've chosen to go with as a society when we do the 12-hour type is ranging from almost 1 in what you call the time, like 12:59, from almost 1 to, well, almost 1 in this case, let me re-clarify. From almost 13, 12:59 is basically almost the number that would be 13, to what actually is 13 resetting at 1. So although this is basically a mod 12 cycle, the fact that it doesn't put a 0 on top and puts a 12 on top makes it range it completely wrong from 1 to 13 instead of from 0 to 12. Mods are supposed to reset at that number, so it should go from 0 to the number that would be 12 being the next 0. Now, that's what the modular tables will look like, and that's how the last digits in bases go. In base 10, you don't go up to a symbol for when it's tens place. You add a 0. So the last 2 digits of a number in base 10 have cycled around that 100 clock, and they'll tell us what the remainder is, essentially, after division by 100. And so if I have like a number like 521 dividing by 100 and just keeping the remainder is basically like keeping the last 2 digits. And if I get 00, that tells me it's a multiple of whatever. So when we look at looping around on a modular clock like that, which we will actually today be starting much lower on mod, if to a degree these are nonsensical to bring up, but there are reasons to bring them up, what would be mod 0 or mod 1? Now, the reason we're starting with those low ones today as our main theme is because this is the first video, or like I want to say episode 1, but I reserve the title episode for my main combo class channel, full episodes. And the first video in this series, I decided for each video in this series, since maybe I'll go live on Mondays at least up through 6 or 12 times to get through some good amounts, will be semi-focused on the mod of the number that we're talking about. And at first I thought, well, that's not going to work because I would want to start on mod 2, like many charts are going to. But I decided, well, we'll start with to what degree does mod 1 work and to what degree does it not work as our mini theme today. But in general, with the idea of looping around on a clock like 100, the reason I bring that up is that if we have the number 99, and yes, this is a long answer to that one question back there. If we have the number 99, then we could call that congruent to -1 because it is 1 before the loop around. And so we will sometimes want to phrase the second half of the numbers under the mod number as negative to give some symmetries. We don't always want to do that. The default is to not do that, but there are many times where it helps because we'll see symmetries, and sometimes it will reduce the amount of things we need to write because we can just write plus or minus this half for certain times when it's symmetric. So now to get to the other questions, because that was a while. Perimeter of an ellipse is incredibly complicated, and there's no simple one like there is for a circle. So we'll have to get into that later. There's not a simple one the way we can graph a circle. What's my favorite math conjecture? Well, I would say right now, the ones I'm really into are the Riemann hypothesis and a slightly easier to digest one, which is such a simple open question that although it's smaller in the math scale than the Riemann hypothesis, it is easy to describe to anyone, making it cool that it's still an open question, and it has had progress on recently, is the twin prime conjecture, whether or not there's an infinite amount of primes two apart. And the Riemann hypothesis, well, I'll tell you the statement of it, but it's going to take a whole episode in grade -2 for me to explain what this statement means. The statement of the Riemann hypothesis is that all of the zeros, and I can't explain what all these words are, that's what the episode will take to explain. All of the zeros of the analytic continuation of the series of reciprocals of 1 over each of the natural numbers from 1 upward to the power of s each, added up for a given s is what you graph, the analytic continuation of that function on the complex plane, whether all of its zeros, the hypothesis, are on either negative even integers or on the line x equals 1/2 plus some amount of imaginary component. So, a lot to unpack there, as you can see. Now, we can talk more about negative mods later, but we're not going to need that negative thing as much in our tiny mods here, because some of them have barely any room for that to be practical. Now, someone's wondering, if we know our orbit is elliptical, then how did the orbit get discovered? Well, the math we're talking about is the equation for a perfect ellipse, which is hypothetical. We can't observe perfect circles even, or ellipses in nature. We're not sure if they exist in nature or not. It's one of the great philosophical questions of life. And there is physical things that we can observe which are separate from those perfect equations. What the physical equations do is they can approach that perfect thing as a limit. And so I would argue there are ways circles exist in nature, but they're the limit of some phenomena. We're not sure if we can observe that limit. Now, ellipses similarly, if we observe something with a trait, we can know a lot about it without knowing a formula for it. We can define an ellipse. An ellipse is all of, you take 2 points that are similar to how a circle has one center, and you make all of the points related to those 2 points with a simple rule. So there's a rule that make ellipses, but as for, they have an equation that's similar to x squared plus y squared equals radius squared for a circle. They don't have that type of neat equation. And to whoever asked why I dress up messy, I don't do it on purpose. I wear my lab coat because it helps out here, and it's gotten very messy during the grade, and I'm probably going to get 1 new lab coat per grade. I know I'm getting a new one in about a month at the start of grade -2, so I'll have a new lab coat each grade, and it will evolve over the grade. And we're very close to the end of the grade. In terms of modular arithmetic, we could say we are congruent to -1 in this grade on a given type of mod, about the size of the clock, because we're in approximately the 11 o'clock state. Now, To whoever gave a little donation, Endo, thank you so much. Those always help. And you can ask a slightly off-topic math question. Can't guarantee how detailed of a response it'll get, but I'll certainly try and answer it. So feel free. And to whoever says that they can imagine mod 1 being useful for digits after the decimal point, and for mod 1 they wouldn't even know where to start, you're sort of on the right track with both of those thoughts. And if there's a difference between mod and remainder, well, mod is somewhat a deeper term, so remainder implies I divided by something, what's left over. In mods, we can make relationships where we don't need to bring division into the question. So a remainder will give you the result in the mod, but the mod tables run a little bit deeper and have patterns that we don't need to use remainders to describe. And there's a lot of similar topics you'll see in math where the same charts show up many places. And one thing I mentioned in this description is that we'll mention something about abstract algebra. And of course we're not going to fully explain that. As you can guess, something named abstract algebra would require many courses and textbooks to fully understand. Well, fully understand is debatable about anything anyways, but to get a good grasp on. But one thing in algebraic number theory, which is, a particular type we could say, in algebraic number theory, which is a category like that, you can look at the mod tables in the context of things called groups and rings that are tables and little rules for systems, little landscapes essentially. Another type is fields, which are little landscapes with sets of rules and sets of numbers that obey those rules. And a lot of the things we are familiar with, like the integers, the positive integers, the rational numbers, the complex numbers, the mod 6 table I've shown a bunch, those are all evens versus odds, which is a mod 2 table kinda, are all secretly, types of these groups or rings or fields which obey certain rules we're used to, but you don't always think about written down. What rules we expect numbers to follow and we've gotten used to. Some of them we take for granted. So, to Endo, who I am going to answer next because donations always help, so that encourages me to get to the comment. Someone said if you drew two random lines, the probability of them being parallel is 0. How is this true, and have I heard of this? I haven't heard of that, but I can imagine why that's the case. Now, this is something that I discussed in the last stream here, which for some reason processed really weird. It might have been because my internet being weird, but YouTube really handled it weird. They made a 2-minute section of it available to the public, and then the whole rest of the stream, they took 2 days to process. And so it notified subscribers about the 2-minute section when that was ready, and it looked like the full length, so you clicked on it, and then it was 2 minutes. But it took 2 days to process the full thing, which looks like it just came out on my channel, maybe. And might be missing the chat, annoyingly. But I don't think that'll happen today. And that stream is available, which is fun to watch, has a lot of good info in it. One thing we went into there, which I'll go into again now, is that probability of 0 doesn't mean impossible. Probability of 0 means as you go to bigger and bigger amounts you test, the percent that did it approaches 0. So 0 is almost like a limit there. Now, the reason that's the case is because if this is my line, I could draw a point somewhere and say, I'll have the line be going through that point. Well, there's an infinite amount of lines that can go through each point, and there are all of these rotations. So these are all rotationally different lines, and there's an infinite amount of them. we cut into 360 degrees, but you could go to half a degree, a quarter of a degree, whatever. Whether you cut it to degrees or radians or what, there's an infinite amount of ways I could make the angle go. And dependent on the angle, what's the chance that this one lines up with this one? So if you imagine that I had 100 dots and I drew a line through each of them, they would probably, if I did it randomly, truly, which is, we can't simulate, but if I was able to, what's the chance that 2 of them would be in the same spot? Well, I can construct a situation where they are. There are, there's a possible chance that 2 of them are. But the chance is essentially 0. With more and more accuracy, you would have none of them do it, no matter how big of a size you tried, no matter how many you made. And so it's possible for it to happen because we can construct a scenario in which it happens, which is different from something that's impossible because we can't construct a scenario. But the ones that, and I mean impossible because we couldn't construct a scenario in any case because it would imply a contradiction or something. But the chance of this is possible, but called 0, because that's essentially what the limit gets to if you had enough accuracy and a bunch of tests. So you'll often see probability of things being 0 or 1, meaning that with big enough sizes, it tends toward pretty much all of them doing it or not doing it. So similarly, there's something called natural density that you should look at. Shows up in one of my main channel episodes. Which one would that be? It would be the natural density. It's in my pan digital numbers episode on my main channel. And we'll see that the natural density of square numbers is 0, even though we can construct square numbers. And so that's a similar thing. So that is the answer to that. Once again, thanks for the donation, and to any other questions here, which I'll try and get to before I get to my random math ranting topics. And someone's saying, so mod doesn't work for imaginary numbers or irrational? Well, in its typical definition, it doesn't, but you could extend it to. Now, the mod can mean different things. You can see a computer program that runs the modulo operation, which just spits out the answer of what something's congruent to. And that's an operation, the modulo operation. But you also could note patterns these tables have and stuff that go beyond that. The modulo operation basically is similar to how the remainder or that spits out one main part of this, but this is deeper within other parts of math as well. And there are many things that could work for imaginary or irrational numbers, but you'd extend the definition because usually you don't include that in your definition. But there are various definitions we could even have for this. And one definition is we are running it on integers. It is an operation on whole numbers. So sometimes when you're talking about it, it's presumed that your inputs are whole numbers. Other times, it's presumed that we're allowing all sorts of numbers, and we might have a fractional remainder. And you could theoretically extend it to those, but in the cases we look at, it's typically going to be going to whole numbers. And once in a while, like if we graph it, we'll be going to fractional numbers. We'll see if it goes to those other ones someday in an episode. And right here, we got more cool, nice comments. Thank you all. Significance of Euler's theorem. We'll have to get to that another day, as well as the parallel postulate. And thank you all for the thoughts here. But to clarify, just because I did see another comment on it, probability 0, we would not call impossible. We would just call, with a arbitrarily large sample size, 0%, close to 0 or 0% of them do it. And it approaches 0 with larger sample sizes, whether we know it's always 0 or it approaches 0. Because if it approaches 0, it'll be there with an infinite amount of tests, as we're basically presuming here. So, thank you all for the great thoughts. We're going to jump into some of today's topic now. And today's topic is going to be, could you have mod 0 or mod 1? Now, often we do think of the mod when, and right now let's imagine we're going to be inputting a real number, we'll assume. We do think of the mod as being like the remainder of something upon division. And under that definition, if we decide to define mod that way, then what it would mean to have something congruent to something else in mod 0. Let's see if I have a pen somewhere around here that still works. And let's say we have nope, this one doesn't work. Okay, it's very light. That's too light. Okay, maybe this one. A, good enough. A congruent to B in mod 0. We're wondering if that's possible. Well, what this would mean is that A results in B upon division by 0. And, well, that's the remainder. It results in B plus a whole number. K times, and we'll say, I don't know, times an integer. So, basically, we're looking at A divided by the mod was some integer plus a remainder of B. And A divided by 0, that doesn't look good. Now, I don't know if you guys can see that very much, but right there. I don't know, that doesn't look good. A divided by 0. So, I'm not sure if you can see that. The glare might be really weird on all of that. You guys can get the gist, though, that our equation we're setting up under that definition requires division by 0, which is not going to be allowed. And as what I said, a poor phrasing of it in my most popular video on here, which has 9 million views now, it's a short about dividing by 0, is I said, well, in most fields of math, it's undefined. But that was a poor phrasing because fields of math, I hope nobody assumes I mean the thing in math, in algebraic number theory I mentioned a minute ago called a field. Because, or what we could also call in abstract algebra in general. But I meant in most branches of math. I'll have to make sure I use branches instead of fields to be clear, because there is a thing called a field in math. We'll get back to those today. So, that's not the only definition we could theoretically have for it, though. We could say that these tables are, like, related to deeper concepts in abstract algebra. And I'm not going to be able to draw the full link to where that goes right now, but I will give you the spoiler alert on that. When you have any reason why this A congruent to B, any two numbers being congruent in mod 0, and you dodge the divide by 0 with a different, more abstract, more, basic, or in other ways fundamental but abstract definition, then it's useless. So mod 0 is either impossible, causes a glitch on dividing by 0, or is useless. So we're not going to have much to look forward on mod 0. However, the main part of this title was mod 1. We're going to have mod 1 be somewhat of our theme today, because this is episode, or not episode, I'm still going to try and reserve that title for the main channel's combo class episodes, but which the latest one's linked in the description if you haven't seen the math language one. But here we'll call it the first video of my streams of the Monday ones, called Modular Mondays, and will go up in mods. It's not going to be the entire episode, but part of the episode, part of the video, is going to be talking about whatever mod it is the number of video in this series. And so it's the first video, we got to do mod 1. But now let's think about how I mentioned in many times we're looking at whole numbers with this. And when we're looking at whole numbers, what would mod 1 mean? Well, our mod basically makes something congruent to a number that's between 0 and 1 less than the mod number, because that would reset it. And that would mean in mod 1 that we're ranging from 0 to 0. So once again, we get, if you define it a certain way, where you say, in this case, the certain way would be, I could define it that I need a range of numbers, 0 to something that's not 0, a range. If it's defined that way, it's impossible, because we have no range. But let's say we allow. Our range means it's just 0, is the number we're talking about in mod 1. Well, with whole numbers, that's really going to be useless. Having any number we input, any whole number, will be congruent to 0 in mod 1. It's basically like how we're using mods sometimes, we're using as an analogy for those clocks. I bring up the clock analogy often, and I'm even going to turn some of these broken clocks into modular clocks with different amounts of hours and zeros on top. And the mod 1 example is sort of like a clock that just has the 0 on top, and I'm like, well, what happens when we spin it past, oh wait, it's the number. There's no others to be on, no other states. And so a clock with just a 0 on top, like, hardly would need a hand if you're just talking about hours. And so if you're just talking about whole numbers, mod 1 is useless. It makes everything congruent to 0. However, we could use mods on non-whole numbers. We could say, what is 2.5 mod 1? And the answer would be 0.5. We could, also say, what is 1 plus or minus 1/6? Well, no, let's a bigger number. What is 10 plus or minus a sixth in mod 1? Well, the reason I did plus or minus there is because we don't want to get tricked of these having to look alike to what they're congruent to. We could call it plus or minus with what it's congruent, and then we'd say, well, we're not going to want to here because we're getting to the remainder, the answer. So in mod 1, we could call it plus or minus 1/6 is all that's it's going to be left. But really we're going to end up with, in the normal phrasing, either 1/6 or 5/6, because 10 plus a sixth has the remainder of 1/6. 10 minus a sixth is 9 5/6, remainder of 5/6. So we can now have abilities to make mod 1 useful if we're ever looking at things like graphs that take intermediate values apart from whole numbers. So To whoever said they're looking forward to hearing about it, but maybe they missed it, not sure if that was before or after this, but there will be timestamps after this episode, or you can always watch it back. No need to necessarily watch these live as they're going, but that can be fun for some. And hey, what's up to the Magic Fellow, who is someone who helps me out on Discord a lot and may be moderating around here sometimes too, although I need to set that up. So, episode 0, mod 1. This isn't exactly episode 0 because I nicknamed the stream I did on Saturday that took until this morning to process, which I don't think today's will do. It had some other weird glitches on YouTube's end. I actually talked to the chat there, so that might have helped, like the support staff. So maybe that's what fixed it, but I don't know. But episode 0 is what I nicknamed that. Now, we are going to have to move over a tiny bit because I'm going to need to plug in here. Alright, it rained out here, so I have to like dump out rain into anything it collects on and crazy stuff. A lot of nice birds, by the way, for you to tune into while I plug this in. I actually was at a party 2 nights ago. Or no, wait, that was, yeah, 2 nights ago. And one of my friends mentioned having learned a lot about bird identification. So I might have them over sometime to try and identify what types of birds we have living up there. So, okay, that wasn't plugged in yet. Hopefully that was it, yep. So, why do we usually talk about whole numbers in mods? Well, that's related to what I'm going to pull up right here, which is, let me make myself small. And here we have some modular tables. So this is mod 12, which if we replace the zeros with 12s, we could turn into clock analogies, like what happens when I go forward 7 hours 5 times on a clock. Well, I'll end up at 11 o'clock. If I go toward 6 hours 4 times on a clock, it says 0. We would have to say, it'll say 12 on the clock because of our dumb clocks, but it would be 0. If I wanted to talk about any time of day, I would have to be in mod 24 if I'm talking about all the hours, but I'm referring to 12-hour clocks. And here we can note that the lowest they have is mod 2, because if I'm talking about integers, mod 1 is, like we said, useless, or even in certain definitions you could make impossible, but usually more along the useless side. But in some ways could be defined as impossible. So ranging from impractical to impossible. And well, I'll let this go. I hope this doesn't do anything weird to the stream running this. So, the lowest they have is mod 2, which we're not going to do much about today. That'll be next week's video 2 of this series. Will get to be about mod 2. But we can note they don't even have mod 1 on this table. And mod 1 would just be 0, 0, 0. That would be the table. Now, when we're thinking about how mod 1 is too low to get a table here, because it really doesn't have any interactions, there's going to be similarities to other things we'll see in math. In fact, you know how natural numbers or whole numbers or different things like that are used different ways, but some use natural numbers to mean numbers from 1 upward, or the positive integers, so it definitely has at least that name, are often referred to. I've been thinking that I need to make a nickname for whole numbers 2 and higher, because there's a lot of things in math that it would be a lot easier to describe with a term for whole numbers 2 and larger. It would save a lot of time if that had a one-word nickname, or like one word to put before numbers. And so I'll think of a good nickname to come up for that. And one of the things that that's common with is what I called basic bases in my second last episode on the main combo class channel, which are the integer bases 2 and greater that follow the typical rules we're used to, positional of powers and so on. And so basic bases and these modular tables make sense to start at 2. The basic bases even have to start at 2, because if we tried to describe them in terms of any of the same rules that the bases 2 and higher followed, they couldn't make numbers, because the rules were using digits ranging from 0 to 1 less than the base. So when we're using the last digit as powers of 0, then that as powers of 1, and powers of that, and powers of that, base 1 would only be using zeros. And no matter how many zeros you put, it doesn't make a number. Now, you can make something called bijective base 1, and you can vary your definition a bit to include tally marks. But a lot of people falsely claim, no, base 1 is the same as how base 2 works, just with 1s like tally marks. It's not. Base 1 would be, by the same rules, impossible, because no matter how many zeros you make, won't make a number. Similarly, if we said these mod tables are mirroring properties of the last digit of a base, what base is only going to have a last digit of 0? So what mod table would that be describing? Now, what about in this abstract algebra I mentioned, these fields and groups and rings and stuff? Well, funny enough, there is something called the field with one element, but it's not a field. It's a title for the concept that would exist if a field could have this property. So it's a funny name, because the thing called the field with one element is not a field. Kind of like how the number 1 is a highly composite number, but not a composite number. Also, the number 2 is a highly abundant number, but not an abundant number, and so on. But in those fields, apart from that field with one element thing that doesn't work as well, often you have one of your rules in one of these landscapes of numbers be that you have identity elements for multiplication and for addition. And those rules we're used to needing in all the systems, like rational numbers, complex numbers, even weirder ones, multiplications and additions we want to have, and we end up wanting an identity element, which is the element that doesn't change things. And the element that if you run an inverse operation on something, which is the negative version of something being added to it for addition, or the reciprocal of something being multiplied to it for multiplication, you get back to that type of identity element, which is backtracking the rule of the identity element doesn't change stuff. And here we have, in the smallest practical mod table and basic base, are 2 identity elements. The addition one is 0, the multiplication one is 1, and we have them both. So, if we were down in mod 1, where we said it would only contain a 0, we'd be missing one of our identity elements. Now, you might say, if we're talking about remainders, that doesn't matter. We can be missing stuff. But what about these relating to deeper concepts in rings and so on in abstract algebra? And tables we could make for groups, and there's a lot of ways in which a table for arithmetic can have these deeper things that it also shows up as, that you could say in some ways really are it, or it's a projection of. Now, in a landscape of numbers like I described those, it's bad to be missing the identity element in most of the landscapes. And we even do have a rule, much of the time, that they must be different. Now, here's a challenge for you folks, if you want. This isn't something you'll be able to answer instantly, so don't look it up and try and post it to brag you're first or something. If you really think about it, it'll take you a minute. What is a proof you could make? And there are simple ones. A little proof using, arithmetic, that you get a contradiction if you have at least two elements in some type of system, and that your identity elements for addition and multiplication are the same number. In other words, if 0, for example, but you could call it x if you want, is a number that when you add it to something doesn't change that, or when you multiply it to something doesn't change that, prove that 0 and some other thing a that you can use arithmetic on, or some set of things, a, b, c, whatever, can't coexist. Turns out you could have fun talking about a system with only one element where they're the same, but that's not going to be very useful. So most of these things require the identity elements to be different. The one that doesn't change things when you add to it, and the one that doesn't change things when you multiply to it. And here we get both of those. So we'd be missing something, or have to merge them in a way that you can prove is incompatible with the rules of arithmetic you like. That if there was only one thing, we'd be missing something or have errors, or have to rewrite a ton of rules. So for all those reasons, 2 starts certain systems. 1 is like the number that builds everything with succession, but 2 sometimes is the first to have a certain property. It's like the first to be either prime or composite. 1 is considered the unit. So here we have mod 2. We'll have to get to that later. For a brief look about the clock thing, to help sink in modular arithmetic, let's go to mod 12, and I'll get a clock here. This one lost its glass recently. And get my coffee, because it's my morning, although I know most of you are watching from other places. So here we got our clock, and here we're going to pretend the 12 says 0, or the 0 there says 12. They mean the same thing in this land we're talking about. This is addition. So if I say I go forward 2 hours, I go forward 2 hours, then I go forward 2 more hours, the result here says 4, and it's true. But, ooh, these are bending. I don't know. There. But if I say I go forward 4 hours, then 9 hours, it's still true, but I looped around. So 4 hours, then 9 hours is 13 hours. And we're assuming I start at the 12 here. I would loop around and then get my answer. So 4 plus 9 is no longer equal to 1, but it's congruent to 1 which is the version of equals in this case, in mod 12. And to those who are like, why isn't there a 12 up there? Similar to the last digit of a base, 12 has to be the reset, not get a symbol here. Or a depiction, or a spot. So we would have to turn them to 12s in some cases, like 5 plus 7, 5 hours, then 7 hours goes 0, which we translate to 12 if we're using a clock analogy. Now, what about if I go a certain amount of hours, a certain amount of times? Well, now we're in multiplication. This is the multiplication chart. There. And all of this is on the Wolfram demonstrations page. So shout out to Rudolph Muradian, I don't know, who contributed this. And shout out to the Wolfram site. Very good math resource. So here we have the possibility if we go 4 hours 4 times, now the multiplication table tells us we get 4. And I hope I was on multiplication earlier. If I was on addition before, well, I mean, I knew I was on it there. I'll double check the stream to make sure. In multiplication now, we have 4 times 4 gets me 4. So whenever we talk about times, we need to be in multiplication land. If I go 6 hours 5 times, I end up at the 6. 6 hours 6 times, 0, so on. Now, what if I want to know which times, if I go through all of its multiples, I go 5 hours, 5 more, 5 more, 5 more, 5 more, something like that, will I hit all of the times as numbers? Now, we're going whole hours now. If we were doing that with minutes, we would now be in mod 60. Same with seconds would be in mod 60. But we're in mod 12 now because we're talking hours. Well, 2 hours at a time is not going to hit all of the hours. And there's an episode called something about spiky shapes on the main channel that goes into this part, but we're not going to hit them all. The only ones that hit all of the numbers on one of their rows or columns are 1, 5, 7, 11. And here's where negatives come in handy. I could say the only ones that do that are plus or minus 1 and plus or minus 5. Because 7 is plus or minus 5 and 11's plus or minus 1. Now, we'll say 1, 5, 7, and 11 for now. Those are the numbers that are coprime to 12 and smaller than 12. Coprime means no factors in common larger than 1. So basically, 2 has a factor of itself in common with 12. 8 has a factor of 2 or 4 in common with 12. So those are not coprime to it. And those don't hit all the hours in this game. But 5 is coprime to 12. No factors in common larger than 1. That will come back because the fact that 5 and 7 are coprime to 12 is part of how the music theory scale works. Not like a particular scale, but the 12 notes total that we pick to divide an octave up into, which I will explain in music theory lessons in grade -2, is cut into 12, and the fact that 5 and 7 are coprime to that makes it work, or is part of why it works. So, we will come back to that. Other fun games we could play, which I mentioned in a different main channel episode called Modular Multiplication Magic, involved things like how the square of any prime number is 1 more than a multiple of 24. I also showed the proof for that in an earlier episode. And with that, we can say start at noon on a 24-hour clock, add a certain prime amount of hours, that same amount of times, you always end up at 1 a.m. Or on a 24-hour or 12-hour clock, end up at 1. So there's other games we could play. Let me know if you think of any other ways to turn it into clock analogies. Now, part of why I called this Modular Mondays is because weeks move in a cycle. Weeks are kind of mod 7. As far as not the day of the month. I wish the day of the month was a modular cycle, but some have 28, sometimes 29, some have 30, some have 31. So they didn't let us have a modular cycle with a single glitch. They made it all glitches. Oh, is that a squirrel? Don't know if it was on camera or not. So, if we replace these zeros with Sundays, ones with Mondays, twos with Tuesdays, and etc., and we go down, we will notice some of them match. 5 Friday, 6 Saturday. If this was 7 Sunday, some have the same letter. 1 Mon, 2 2, 3 doesn't match. Should be, but you could call it, 3 could be Thursday. You called 3 for some weird reason. I don't know. There are ways you could try and match it up. It's not matched up perfectly, but here there's actually a post on the subreddit about that, on the combo class subreddit, with other suggestions. But here, if we replace zeros with Sundays and etc. to 6 being Saturday, we can play those games. Go forward 3 days, then 3 more days. From a Sunday, you end up at Tuesday. From a Sunday, go forward 4 days, then 5 days. Wait, no. This is multiplication. Sorry. I forgot the last one I did, but it would have been that day that many times. So go forward. Additions here would be like go forward 3 days, 4 times 0. End up on Sunday. If I start there. If I go 3 days, then 4 days. Got to keep these together. Here's if I go forward 3 days, 4 times from a Sunday. I end up on a Friday. So, interesting patterns here. Now, this shows square numbers on the diagonal, like 0, 1, 2, or 4 only, means from a Sunday, if you go forward any number of days, that same amount of times as the amount of the day, or so you could go forward like 12 days, 12 times, then you'll always end up at either the same day you started or 1, 2, or 4 days after. Never 3, 5, or 6. Now, cubes are even better. So watch the modular multiplication magic episode on the main channel if you want to see how cubes relate to this. We'll also re-clarify it in episode 7 if the stream goes that long. I promised them through at least March, but we might keep going. Might go through April and onward with these Monday and Thursday streams, which I probably will do other random streams between, and it probably won't change the amount of streaming I've been doing. Probably just going to fix a few points so that people know, like, have something to look forward to, plan a good time to ask me a question, or have, one of the two they expect to be available for, like the Monday for me mornings or the for me Thursday evenings. which those will be more on the computer, and they will also involve a puzzle. There is on the Discord one puzzle out so far, which the Magic Fellow is running. Well, I mean, I'm running it with him, but he put the first puzzle out, and he will be, for the start of it at least, contributing the puzzles. And the first puzzle I will go into here. It has to do with modular arithmetic, the cleanest way to answer it or describe the solution. But I won't go into the answer. I'll just note that modular arithmetic might help. And if you look at the Discord, there are spoilers there, but the spoilers I think might have spoiler text over them, so you might be able to dodge that. Only in that one section would be spoilers anyway, unlike that one thread. And I'll go into that now, I guess, because for those who want to puzzle through that, who aren't on the Discord, I will be going through the answer to this next stream on Thursday. And I didn't have a time to announce the last one here, but in the future, on the Thursday streams, which I'm nicknaming Threeven Thursdays because I like the name of that, but it's only going to have a mild amount to do with Threeven numbers each time. It's going to have random different topics, but we'll have a recurring puzzle segment, which will be near the end of the stream. I will, the Thursday stream, shout out whoever got the first and or whoever got other interesting extensions or solutions to a puzzle that's mentioned each week. And then I'll be shouting out the last week's winners based on who posts on the Discord. So sorry to people who can't post on there. Theoretically, if you want to try and submit a solution in a comment here, I might try and implement that in the future somehow, but for now, just the Discord. And try not to post a solution in the comment. If you do something like spoiler and then leave text or space so that it has to be clicked, like read more or whatever, because it's better for people to think through them themselves. Part of why I'm doing it is because it's a fun segment, shout out some people. I like puzzles, present one and talk about the solution to the last one while shouting out the people, like go through some fun details about the solution before presenting the next one. And with that, part of why I'm doing it is also to train your brains, because I do a lot of puzzles for fun, and in my life have had a lot of fun thinking through them. So maybe that's part of why I, know a lot of math or have certain math topics I'm sharp in, is that I've thought through a lot of this stuff myself, not just being given facts to read, which I do consume a lot of facts too. And I give you folks a lot of facts. But on top of those facts, it's good to check your knowledge once in a while and check your abilities by running through a few solutions, going from a question to an answer yourself. And not only will these puzzles do that, but so will the final exam coming out in 6 days, which will be a fun video even if you don't like tests, and hopefully will, throughout the video, encourage some people to actually try it, which it will have its questions gone over in part of the video, and we'll also have them in a text document somewhere in the description. So that'll be fun. Now, this isn't going to help us with today's mod. Today's mod is mod 1. For that, we're going to need Desmos. We're going to look at some graphs as a good way to view fractional things in a mod. But first, one thing I skim past is, why do we use whole numbers? Well, a lot of mods have cool patterns with tables like this, addition, multiplication, or other tables you could make. And those are the tables that are at the heart of some even deeper math at times. But if we tried to do one for all the rational numbers, That'd be an infinitely big table. And I couldn't start it numerically. I would have to go down like, okay, I'm going to order it by denominator. So I go 1/2, then 1/3, 2/3, then 1/4. We already did 2/4, 3/4. That's known as a fairy series, but that would only start to list all the ones between 0 and 1. Or actually fairy sequence, because a lot of people call it a fairy series, so I get confused. But series usually means you add up the terms, which we're not doing here. Like, no long sum. What we're doing is imagining ways to make all the fractions. And it would be, you'd have to use that method even to start listing all the infinite amount between 0 and 1. So you're not going to be able to make a good multiplication table like this for the fractions unless you have some limit. You could do mods including fractions up to some denominator, and I would like to see that. I haven't thought about that, so that just came to me. That could work theoretically. So if anyone is a programmer or just wants to try by hand, try whipping up a mod 6 table including all the fractions between 0 and 6 that have a denominator between 1 and 6. So that'd be fun. It would be kind of like, we'll go into the, I was going to look up fairy sequences, but we're going to go into those another time in more detail. And there is a short or two about them on this channel. So, Desmos is where we'll need to go for mod 1, but let me check the comments first. I know it's been a minute. So, I'm going to make myself big again for a moment to check these so I can just do it on the computer instead of my phone. That makes it easier. So, someone's wondering about... Oh, and also, this is a good one. The Magic Fellow notes, reminds him of the 1 equals 2 false proof. And a lot of those sneak in divide by 0 errors, like the one I showed. There are other ones I'll show in the future. They use other tricks, but it is true that similarly, you can get glitches like that within a system where you have multiple elements, but the identity element was trying to be both. And why are the identities different for multiplication than addition? I'll have to go into in a longer video when we go into all our axioms and stuff. Or if people are curious about a question I can't answer, a good place to look it up is see if anyone's asked your question on the site Stack Exchange or the math part of it. Maybe called Math Exchange, or maybe math.stackexchange or something. That happens to be a really good forum for math questions to get actual smart answers. Or the subreddit someone mentioned is not bad. There's good stuff on there too. I do read through it in my spare time sometimes. Someone said they're liking the live. Glad to hear there'll be more. And yep, you probably already know, but check the description because this is part of a schedule that will continue. So, not able to answer all the questions. Thank you for leaving all the comments. And we're going to go back to me being kind of small. And looking at Desmos. So, here is how they make mods here. It's a graph here, normal coordinates. And the way they say y equals x in mod 1 is this. Y equals mod of x comma 1. So, this is the coordinate points. where the y coordinate equals, well, let's start with this first. Y equals x. This is what it is modding out. Y equals x. Then we could say they're trying to make this under mod 1. We imagine we just want the remainders, right? And that's what you get. So we can note things like here from 0, they do give a high result for the negative. So -1 point, let's see, -0.1. Let me think of how I want to explain this. 1 second. So they are interpreting the negatives as the backwardsy way, where on a clock we would call 11 also congruent to -1. Because here we can see that something like -1.1 is putting out 0.82. Because the -1 gives us nothing in the mod 1. It's a whole number. The -0.18 is, to them, telling it 0.18 under 1. So remember that negatives here are playing that rule where they loop around at the mod. So here is where the y coordinates are equal to the x coordinate when the to the x coordinate in mod 1. So here we can see like our remainder there is a little more expected in the positive region. It's the remainder. So what about something else? What if we say, what are the coordinates where y in mod 1 equals x in mod 1? Well, we get an infinite amount of lines. The lines stretch. It gets glitched out at times. There we go. Stretched out lines. How about where the y coordinate's more? Ooh, it fills in a secret thing there. Isn't that interesting? The equal sign is sort of hiding this inequality. Makes you wonder exactly what's happening at that barrier. Now, what about this? Throwing a sine into the mix. Sine of y is mod of sine of x, or this means sine of x mod 1. Look, x's and o's. So we get this whole infinite field of x's and o's. They have little glitches in the o's. There's a little dot there. It makes it wider than it is to show you, but the fact that I can keep zooming makes me think it's an infinitely small point it doesn't work for, and the rest it does, unless that's a glitch. So, O's with holes and X's. What about inequality? That's cool. Looks like a chain of candies. So, what if we now put the mod and the sine together, where we have mod of sine of y, 1 is there. Ah, cool grid. And if we replace one of them with tangent, this one it's having trouble computing. This one has infinitely dense parts right there. Maybe if they're both tangent? Well, that's even crazier, but pretty cool. Now let's zoom in and see if it can get more detail on part of this. When you zoom in on some of these, you get this perspective thing where it looks like a long, like tube-like thing going downward or upward. Okay, so that's that wild one. Now, we could have all sorts of ways of experimenting with this, one of which is to make the mod a slider, and we will set it to integers, so it'll still have fractional values it lets, but we'll also be looking for every other integer it cuts off or flips back around. So we'll go step 1 from 0 to 10. No, to 24. Whoa. That's wild. Let's start it at 1. So, back to the sine one. It's not liking that one. There we go. What's going on here? Let's take a closer look. Well, that cuts that part out. It's having trouble with that. So, what if we have that one slightly off? Now are we just growing or shrinking them? What's happening here? Whoa, a lot of triangles. Alright, I'm getting distracted by just playing around with the Desmos equations. There's a lot of crazy ones we could do. If we start playing around with like y squared in mod 1 compared to normal x, we can start getting these weird patterns. We can start trying to make them both squared, and that gives us other weird patterns. Whoa, no. And there's lots of things we could alter about these. One we could try is removing the squared, but when you try and make the mod one of them, like if the mod they're in is one of the variables that's the same variable as these two axes, like here is x, y mod x is x or is more than x mod 1. Now let's flip this to see these fellas, these rays radiating off. This one goes forever there. And they all go forever in their own line. These it's having trouble seeing, but they're just thinner ones that repeat. So that's cool. Now, if we say x mod y, boring, but x mod x also, boring. Them both in each other's mods? No. We need to make it to this, where we can alter the sliders. Oh, look, as this line ticks forward, it pushes them, and it makes them grow as it pushes them. All right, well, we went backwards. Now we have the reverse image of them. That's cool. That's wild. All right. Time to go back to the chat for a moment. And the birds are really going crazy this week. Maybe more of them moved in, or maybe they're just migrating past here, but I really hope they moved in. Here's where they are. Hard to see, but you might see some tiny ones. I can. And look at those sunny and cloudy, but good clouds. Skies. And whoa, look at those skies. But it was raining, and we do have rain around here in certain things. And it has caused chaos. And there's a tree I got. That fell off my neighbor's redwood and landed outside my window. So I put it there. And there's the schedule. Alright. So, what else do we have? One thing I thought was fun was, oh yeah, I said I'd check the chat before I jump into that. Chat checking time. All right. All right. To whoever asked where I live, I am in California, in the Bay Area. And that's cool to whoever's sharing their post there. To whoever uses Reddit, not only are those cool suggestions for Math Ones, check out the Combo Class subreddit and add some posts there, because got some cool ones so far. But more of the chatting's been happening on the Discord. But personally, although I love the Combo Class Discord, that's the only Discord I use. And I do use Reddit for fun, just to like look up memes or random conversations that people are having or whatever. But I don't know. I don't use much social media, and usually I use like YouTube and Wikipedia and the sites you see me use. So, let me check here again. And to whoever said they thought I'm Russian, no, a tiny bit of my ancestry was Russian, but not much. And I've never been there. We got someone from Vallejo. That's cool. All right. So, gonna shrink again and look at a different, unrelated topic. So, on Modular Mondays, because we called it Modular Mondays because the week has that weekend tick, and I wanted Monday in the title, and I was like, it moves modularly. I also figured, well, why don't we try and acknowledge the week flipping around? Because it'll be 7 days between Mondays, and in those 7 days, I'll cover some random stories from my life. Sometimes you can reflect on things in your life, things you did that were cool, things that you got to finish, things you have for goals for your next week, or whatever. And one thing that's fun we could do is look at what random holidays might be occurring in the next week. Now, one that I noted as far as funny holidays, that these are all somewhere official, but some of them seem to just have like 1 or 2 articles as their source, that you can't find much more about them, but some are more official than others. Some are also mildly corporate, like National Oreo Day. But with that said, you got some good ones, like Fun Facts About Names Day. That's a great sounding holiday. And if you look at it, it's like, yeah, celebrate the day about looking up information, interesting information about and fun facts about names, and share what you find with others. Try to figure out information about your own name, both of your first and last name. And that's funny timing, because to whoever just asked if I'm Russian, they might have thought that because they saw that my birth name is Dmitry somewhere, but my parents just like that name. It's not related to anyone who was like Russian in my past. But by the way, Dmitry is not that far from Domotro. All I did is switch the I's to O's. And you guys can think about your names. Don't leave a comment with your first and last name. That's bad for your privacy, unless you are the type of public figure who does that. I have mine in the credits of my episodes. What can I do? But, I wanted my name there, but I don't care. So you should probably not leave your first and last name in my comments, but you should think through it on your own. So these looked fun. Look, they have lists of cool stuff. So we're going to look through these lists in a minute, but first, what holidays are going to occur in the next week? And what week is this? Let's see. Celebrate Your Name Week. Oh, squirrel. I hope you saw it. I don't know. Sometimes they start from there, so you might not see them. But sometimes they start from there or all the way over there, so hard to know. Oh, and the squirrel. Check this out. Where is it? I don't know where it is, but I gotta find one next time. It's been leaving walnut shells. Shells of whole walnuts. I don't know where it's getting walnuts. If there's a walnut tree around here, or if someone just like hooked it up. But that's a lucky squirrel. It has walnuts all the time. So we got various months. As far as week, they say Celebrate Your Name Week, Dental Assistant Recognition Week. Very random, but sure. Recognition to people in random professions like that is important. National Cheerleading Week. Okay. National Consumer Protection Week. I don't know, whatever that is. And other ones. Write a letter of appreciation. That sounds good. Return the Borrowed Books Week. I guess that's good. All right. Read an ebook week if you don't like reading the other way with paper books. Good week to do it. I like paper books, but ebooks, basically still gives you the words. So, what holidays are coming up on single days in the next week? We're not going to go through all of these. Like, you can read them here, but this is always one at the end. It's a different link, but the rest are days that have been claimed as today. Now, as far as tomorrow, you got these. And I'm only going to name if there's any really important to me. My friends had a Purim party a few days ago. That was very fun. Oh, Unique Names Day. It's all about names. Does this have the same links or different links? No links. Oh, one link. I feel like unique names, read about unique names. You could just come up with some random name, anything could be a name. Oh, here's a unique name, Glaborgelo. That's very unique, but I guess they mean unique names that more than 0.01% of the population has, but still less than 1% because it has to be unique. I don't know. But anything could be a unique name. One funny one is people often think Dimitri is short for Demetrius, and while Demetrius is a common name too, and maybe even more common in where I'm from, Dimitri is not that common here. I don't meet many of them. When people hear my birth name Dimitri, they often think it's short for Demetrius, and it's turning a 3-syllable name into a 4-syllable name. It's adding an extra syllable, assuming it was even longer. And so sometimes I like to say, as straight-faced as I can, the longest suffix I can. No, it's short for Demetrianopoulos, but an even longer suffix. So that's fun. But we got more name ones. I guess because it's name week, they're giving them all away to all the days too. All right. This sounds bad. Be Nasty Day. What's going on with that? I don't support this. What? Celebrate the day by being nasty to others. Call them names that don't do any of this stuff. This is a terrible recommendation. I do not endorse that. All right. So now we know that there's, many categories of days. There's the ones that probably have only been mentioned by one person, but it was in an article, so it gets here. The ones that are super cool. The ones that are super corporate looking, as for who started them. We passed by National Oreo Day a little bit ago. Is probably whichever corporation owns that helped get that on the map here. And you also have the ones that are just terrible advice, apparently. That Be Nasty one. What the heck? All right. So, I support people. You can have a wild energy. You can say what you feel like. Sometimes you can get into disagreements. That will happen in life. Once in a while, you'll even get into arguments. You can, be confident about your opinion. But don't go out of your way to be nasty. All right. Panic Day. Okay, who's starting these terrible recommendation ones? I don't know who got all of these on here. Panic Day sounds like another terrible recommendation. I'm not even going to click that one. All right. A lot of random ones. And getting close to the next week. All right, and we will finally look at what ones will be happening on next week's Monday stream. All right, I don't know if we're going to celebrate any of these, but still cool, None of them sound as bad as Be Nasty Day or Panic Day, so low standard, but they're good enough. All right. So, one thing I wanted to know real quick, since I have my tabs open right here. Well, no, let's look at the fun facts about names. We're kind of on that thing. I'll get to the other one in a minute. So, these sound interesting. Well, some sound more interesting than others. What about people with really long names? That does sound interesting. Like, it would be kind of weird to have a really long name. You'd have to go through a lot of conversations in life where your name came up. So, after a little bit, you'd probably get annoyed of having a really long name, I'd assume, because it would just cause like a lot of times in your life where you have to spend time explaining something or changing some form or something. I mean, like this. Hubert Blaine that. That would be, oh, whoa. Look at his full name. Whoa, they just didn't put his name in the title. Why do they even have titles? The title is just part of his name. Like, this doesn't need titles. You could just say the name if you're just going to have the title be the name. So, oh my God. Is that one word? I don't see any more capitals and after a space. Oh my God. That would be a really hard name to handle. This must have been before like automated forms and stuff. I don't think they even allow that anymore. There are band names. We'll look into that for an episode someday. It's kind of funny. Different regions have different names that are banned for various reasons. Okay. That one's real long. This one's... Whoa, this guy just has a really weird name. Oh, but he changed it himself. He wanted to change it to all of the James Bond movies. So his name is James Bond, but he put all the James Bond movies as titles in between. I feel like that's like a way lamer way to change your name to James Bond than other ways you could. Like, it would already be probably come across pretty cheesy to change your name to James Bond, trying to be like that spy, but, the fictional spy named James Bond. But I feel like it would be a lot cooler to at least just go with that than to stick all of the film names as titles between there. Or did they like misinterpret him or something? Yeah, James Bond at the end, and then in the middle I want something that represents all of his films. Oh, you want it to represent all his films? Okay. So, these ones aren't as long. Did they start with the longest? Whoa, but this one's Pablo Picasso. I didn't know his name was so long. Now, no singular name in here is very long, but he has a lot of names. A lot of middle names. All right. So, that's our holiday thing. The other thing I wanted to mention real quick on my tabs here is there's a conspiracy about the shape of raindrops. And I mentioned this once on the main channel, but I don't know if you all saw that episode. So, everyone thinks raindrops are shaped like what most of these pictures are. This is a Google search for raindrop. Look at what they're all drawing it as. What you'd expect the raindrop shape to be. But it's not, as that says. This is not a raindrop. This is more like what a raindrop looks like. You see this picture? That is more like an actual raindrop. Now, a small enough one can be spherical-ish, and a larger one will be sort of like a hamburger bun shape. So, they don't fall spiky like this. And, part of it could be that when they dangle off something, they can kind of do that. This is way exaggerated, but
they can sort of drip off something in that spiky-ish shape. But when they're falling on their own in free air, they don't look like that spiky thing. Some cartoonist somewhere decided it was easier to just make them spiky for some reason to show that they were falling. So they made them spiky. Mixed with the fact that they sort of look like a long line going down when you really see them going down fast. You know, raindrops look like they're like shooting down almost like a trail because they're going faster than our eyes can pick up every bit of it. And so we sort of get the idea that they're like shooting down in a bullet-like way, but that's not the shape they are. It's more like, that looks more like a regular one, or a smallish one, and that looks more like a medium one. They're like flattish. So I don't know why that conspiracy has continued for so long. Alright, now I'm going to go back to the chat for a moment. And we're not going to stream for too much longer. We're usually going to do our streams on the Mondays and Thursdays for 2 hours. So usually they'll be somewhere between an hour and a half and 2 hours and a half. So looking at our chat for a moment. Oh, whoa, somebody put way too many comments. Gonna hide all of those, but I really appreciate it from them. But I just can't encourage it. So if that person's still watching, there's a nice message. I really appreciate it. I will reallow you to post after this. I will reallow it after the stream. But I can't have you post for the rest of this stream because that was way too many. So maybe I need to put the rules for my streams at some point in the description, but they are pretty much the self-explanatory rules, you know, the ones you'd expect. So all right. And someone said I'm an inspiration to their classes. That's super awesome. I've wanted to, I assume that means they're teaching some sort of classes, and I really want to get combo class into more schools. At some point, I'll try and make a holiday on that list that's tell your teachers about your favorite online educators. And for you guys, it'll boil down to, my recommendation will be, it's tell your teachers about combo class week. But to get it, you know, more accessible for others, we'll say, tell your teachers about your favorite online educators. And I do want more teachers to know my stuff, to not only have cool things to incorporate into their lesson plans, but to maybe show my videos to classes occasionally. And if you go on the main channel, the one called Combo Class, those are probably the most likely you might show to a class. Although they're a little bit on the longer end, 15 or 20 minutes sometimes, they do have, you know, the most condensed, thorough look at a particular subject. So, now, let's see. Hello to everyone there. Thank you all so much. And I am going to get ready to wrap up in not too long. So you can feel free to leave any more comments in the next 10 minutes. We'll be ending at noon, which is 10 minutes from now. And in the meantime, what I will tell you about, and what I also am going to do is I'm going to remove that user. I'm going to I added that user back, by the way. Just the messages are deleted because I felt bad because that user said a really nice comment, So now the user is back allowed. They're just, the comments were gone where they were spamming. But thank you to that comment. So, what we are going to discuss real quick is what is going to happen upcoming that's going to be fun that I'm going to film is, apart from the rest of the test episode, which I've filmed the intro for now, and in fact, you might notice, well, I don't know if it was visible at any point, but that there's some new ash on the campfire, and there was a little fire in the intro, because it's a different type of test in ways. And with that episode, I'll be filming the rest of that soon, and then also filming some scenes for the finale, because we're getting close to the time where I'm going to start doing my last main activities of the grade, which will include some philosophical scenes of explaining things about the grade while including flashbacks, a variety of flashbacks, and it will also include a field trip to something clock related, but also something natural, and it will also include a little camping trip where I'm going to have another type of campfire here to actually roast some food on for dinner and set up a tent here and camp here in the combo classroom and see if there's any critters at night or any other fun things. And let's see. And there'll be a lot of other fun stuff, but I want to answer these two questions before I log off in case any others come. So as far as the questions, to whoever's wondering, the value of infinity being negative 12/7, I haven't seen that one. I've seen people say it's negative 1/12 before, but value of infinity being negative 12/7. I have not heard that one before. I'm not sure what's up with that. Let me see if there's anything, if I search that up, if I get any clues. I'm not even seeing any results for that. If you meant negative 1/12, then that's not true. That if you mean the thing where all the positive integers add up to negative 1/12, that's not true unless you use a alternate version of what add up to means. So, as far as the other comment, I do know about lazy caterers numbers. I think I've even done a short about them, and they will come up in more future episodes, because there will be a lot of similar integer sequences that show up when we do polygonal numbers and polyhedral numbers and all of the polytope numbers and even other figurate numbers, which are the names for numbers that can be made from drawing dots like we draw triangular numbers. But did you know that not only triangular and pentagonal and stuff are a type of polytope number, but so are tetrahedral numbers, cube numbers, square numbers? You know those from other contexts, you know? And maybe not tetrahedral numbers, but you definitely know square and cube numbers. So did you know that cube numbers have friends, tetrahedral numbers and other stuff? And did you know that, well, you could argue that those are a little different. There's the pyramidal numbers. But in a way, the friend of the cube would be the square pyramidal number. And the square pyramidal number would have friends with other pyramidal numbers if you consider that to be like polygons with other polygons. And square numbers are friends with triangular numbers in my world. So if someone's wondering a geometry question, you can feel free to ask. I may or may not have time or desire to answer it, but feel free to ask. All right. So, and trigonometry, we'll go more into trigonometry in the future, but the value, if you look at certain things, is not always positive when you look at trigonometry. You can have negative things in trigonometry. So, but if you're looking at the way, like the certain trig functions that just compare, I'm talking about a triangle, this divided by this or this divided by this. There are circumstances where all of your trig functions would result in a positive thing just by being a comparison between two positive things, you know? So, I think that's most of our questions people have asked today. And we will be logging off in a moment. This week you can look forward to some random shorts and bonus videos as usual. And there will be the next stream like this, maybe on one of the next 2 days if I randomly do one, but definitely, whether or not there's one between, at Thursday later in the day. So probably a whole different batch of people than this, unless you happen to be at the right time zone where both of those are good times for you. But the other, or unless you're such a super fan that you must stay up to watch it, I don't know. But you don't need to worry about catching both of them live, or either there will be timestamps after of the different topics, and they will be available as streams after. But it will be 6 p.m. Thursday. And hopefully YouTube processes this video right, because last time, like the last stream I did, processed so weird, and people who had notifications on for me. I know because one of my other channels I have set to see what it's like. It has it set to get notifications from it. Got notifications for a 2-minute clip at the end of the stream, but it looked like the full stream until you click it. Then YouTube played a 2-minute part of it, of just the ending of the stream, of me saying like, this part, hi, bye guys. But then it did process the whole thing. But I had talked to their support in the meantime, so who knows. Hopefully this one processes right away, even if when it does reprocess, it might not be HD for a little bit. So if you want to watch them HD, you can always watch the streams like 2 days late. And now I am using the HD webcam I have, so it should show up as an HD video a day or two from now. But it should hopefully show up at least as an SD video right away. I don't know. We'll see. In any case, thank you all so much for joining me. You're all my combo lords. And also linked in the description, we got those classic links like the Discord, the subreddit, and the Patreon that are great places to check out. And hope you all have a wonderful one. I don't really have anything else to say at the moment, but it's going to be a very fun month. So stay tuned for a lot of interesting stuff going on. And a month from now, grade -2 will have started already. So we are now in the time for me to fill in the last craziness that I feel obligated to pack into the grade. And I love you all. I'll see you in the next one.